Hello and welcome to our Objective 2.7 sample problems where we're going to get some more practice solving trig equations. So for these first three equations, we are going to look where theta is between 0 and 360 degrees. So we're going to leave our answer in degrees. Let's start with letter A here. 1/2 equals 1 plus the sine of theta. So all I need to do is subtract 1. When I do that, I will get sine of theta equals negative 1/2. So keep in mind then that sine is our y value on our unit circle. So all I need to do is find where y equals negative 1/2. So let's pull up our unit circle here. I'm looking for y values of negative 1/2, where I see 1 in the fourth quadrant. And if this value is negative 1/2, that means this one is as well. I'm looking for the degrees of those angles, so that would be 210 degrees and 330 degrees. So let's go ahead and pull up our notes again, our sample problems, and we'll see that sine of theta is 210 degrees or 330 degrees. And those are our two values for theta there. All right, let's try letter B. So cosine this time. So I'm going to start by adding 2. When I do that, I would have negative 2 equals negative 2 cosine of theta. I can divide by negative 2. And negative 2 divided by negative 2 is just 1. So that tells me that cosine of theta equals 1. Remember that cosine is the x value. So I want to find where the x value of our unit circle is 1. And I actually know that one off the top of my head. There's only one spot where that occurs, right? So this is a situation where we are only going to have one solution because there's only one spot where cosine of theta equals 1, and that is at 0 degrees right there. Okay, so on our notes, let's go ahead, or on our sample problem, sorry, I keep calling these our notes. Let's go ahead and write theta equals 0 degrees. And remember, I'm saying 0 degrees because we want it less than or equal to 0, strictly less than 360. So that's why I'm not saying 360 degrees. All right, last one. Letter C, we're dealing with tangent. So I'm going to subtract 5 from both sides. When I do that, I will have 2 equals negative 2 tangent of theta divided by negative 2 divided by negative 2. So this is going to give me that tangent of theta equals negative 1. So remember that tangent is y over x. So I'm going to be looking for y and x values that are opposites, right? One is positive, one is negative. So let's go ahead and pull up our unit circle. And when I do that, I will find, let's see here. So these are positive, positive. This is one example of negative, positive at 135 degrees. And the other one would be down in the fourth quadrant at 315. So this one, our theta, will be 135 degrees and 315 degrees. So let's go ahead and write that on our sample problem. So theta will equal 135 degrees and 315 degrees. Fantastic. All right, let's try it now if we're doing it in radians. Let's have some fun here. So, we're going to start with tangent on this one. This time, again, radian 0 to 2 pi. We'll leave our answers. So if I divide by 2, I get tangent of theta equals the negative, well, the 2's would divide out. I'd be left with just the negative square root of 3. All right, so think about this one. Tangent, remember, is y over x. So I'm going to need a y value and an x value that simplify to negative root 3. So that means my y value is going to have to be root 3 over 2, and my x value is going to have to be 1/2, and I'm going to need one to be positive and one to be negative. So y value, root 3 over 2, x value, 1/2, one positive, one negative. Let's see if we can find that. So a y value of root 3 over 2. So that happens here. However, they are both positive, so that's not what we're looking for. It also happens here, where one is positive and one is negative, so that can get a star. That's what we're looking for. And that is at 2 pi over 3. Down here, they're both negative, so not what we're looking for. However, we have a positive x and a negative y right there at 5 pi over 3. So that will work for us as well. So 2 pi over 3 and 5 pi over 3 will be our thetas for this one. Let's see here. Here we go. So theta will equal 2 pi over 3 or 5 pi over 3. Fantastic. All right, let's try letter B here. Now, letter B looks a little complicated, a little complex. Just simplify this. Let's put all of this over 5 here. So minus root 3 over 5 equals -1 plus 1/5 sine of theta. Okay, so -5 divided by 5 is -1. So this is really -1 minus root 3 over 5 equals -1 plus 1/5 sine of theta. So -1 on both sides, I can get rid of those. Adding 1 to both sides would do that. And then I can multiply both sides by 5. And when I do that, I would have that divides out, that divides out. I would have sine of theta equals the negative square root of 3. So let's see on our unit circle if we can find y, remember that sign is y, to be just negative root 3. All right, so y value of negative root 3. Well, I have a negative root 3 over 2, but notice there's no y values of just negative square root of 3. That means that on this problem, there is no solution. There is no theta that will have a sine value of negative root 3. This is just no solution. All right, last one, letter C. So we're dealing with cosine now. Let's subtract 2 from both sides. 3 minus 2 is 1 equals -2 cosine of theta. I can divide by -2. I can divide by -2. And I find that cosine of theta equals -1/2. Remember that cosine is our x values. So we want to find x values on our unit circle that are -1/2. So let's pull up that unit circle. -1/2, oh, it just so happens that I had one highlighted there. And another x value of -1/2 will be in the second quadrant here. And that would be it. Those would be our two solutions. So 2 pi over 3 and 4 pi over 3 is what we would write for theta here. We would say theta equals 2 pi over 3 or 4 pi over 3. Hopefully you're feeling a little more confident with these. Solving trig equations, it has a lot to do with reading the unit circle. If that's something we still need to practice, we can do that. Otherwise, go ahead and get started on those practice problems, all right? Go ahead and get started on your 2.7 practice problems, see how you do. The first couple problems, practice just reading the unit circle. Be sure to check the answer key. Make sure you're doing everything correctly as you complete those. All right, this is Mr. Carter signing off. I'll see you next time.